Hi, I am Christina. So for this problem, first we are asked to find the domain. So I want to look at my function and consider what values for x will not work for me. So to do this, I'm going to set my denominator equal to 0 because I remember I can never have a 0 in my denominator. Great, so when I'm working with absolute values, I split up the absolute value equation into two different equations. One where I maintain x minus 1 is equal to 0, and then in the second equation, I want to distribute a negative sign through the absolute value. This is going to account for the fact that we don't know what is inside of that absolute value sign. It could be a negative number that then becomes positive, or it could already be positive. So we need to break it up into two equations. So again, I'm distributing a negative sign. That'll become negative x plus 1 is equal to 0. Then I will solve for x in both scenarios. Here, this becomes x equals 1, and over here, this will actually become x equals 1 as well. So what that tells me is that my domain will be all real numbers except when x equals 1. So the domain, all real numbers, so as long as x does not equal 1. Great, now we are asked to fill in these tables that we are given. Now a quicker way to do this would be to use a graphing utility. I'm going to put my original function into my graphing utility. On mine, I press the y equals button, and I'll go ahead and input this function. Now when you get to the denominator and you are inputting that absolute value, again, I'm always very careful to separate my numerator and my denominator by parentheses so that I don't wind up having any errors. When I get to the denominator and I'm ready to use the absolute value, on my utility I press math, I scroll over to the number heading, and I will see mine says ABS, abs, for absolute value. I will click that. That'll let me input the absolute value part of this function. If I press graph, I'll go ahead and see the graph of this function, which matches what we were given in the original problem. Now from here, to help me fill out this table, I can go ahead and use my calc feature. Now on my utility, I press second trace. That brings me to my calc feature. The very first button for me says value. I want to press that, and it's going to prompt me to enter in an x value. I'll then go ahead and enter in 0.5. I press enter, and it'll give me the y value, which is 3. So what I'm going to do, there's 16 different things I need to input. I'm going to repeat those steps 16 times to come up with all of my values. Again, each time just putting in the x value, and they will give me the corresponding y. So go ahead and do the same thing, and you're going to input all of your x's to output all of your y's. So the last part of this question asks us to discuss the behavior of the graph near any excluded x values. Now, we recall that the only x value we've excluded is x equals 1, because x cannot equal 1. And then when I look at the graph, at its behavior at that point, I see that from both directions, we are approaching infinity, from both the left and the right, as we approach x equals 1. So I might write that as just approaching infinity. Approaching infinity from the left and the right at x equals 1. And that's it. That's how we complete this problem.